So we're gonna make a speed feed calculator, just a down and dirty one, easy to use, and it just works. Nothing fancy, it comes up quick. So I love using that thing. Instead of having to pull out your phone and use that machining calculator, go on a website or trust whatever CAM system you're using's calculator, because I haven't run into any of those that give you the right speeds and feeds. So what we're going to do first is open Excel and then go save it as something. So I'm going to save as, look here, wherever you want to save it. Mine won't save to, there we go, Dropbox. So, speed feed calculator. Yep, that sounds about right. So we're going to save it there. Here's what your finished product will look like. You'll be able to type in your surface foot. So 100, your tool diameter, 7/16, how many teeth it has, it's drill 1, feed per tooth, and then it'll spit out your numbers here. And if you're using smaller diameter tools, they typically go above the max RPM of a machine spindle. So if it's an 1/8 inch end mill at, let's say 600, well, it's going 18,000 RPM, but your spindle max on your machine, let's say, is 8,000 for a mill. Well, you can't run 36 inches a minute because your machine's only going to turn 8,000 RPM. It needs to be 16 inches a minute for an 8,000 RPM spindle. 10,000 RPM spindle would be 20 inches a minute. So that's going to be our final product. So to get started here, we're just going to go type in SFM, surface feet a minute. Down here you'll want cutter diameter. We'll make that bigger. And let's change our font sizes, make it bigger. I don't like looking at small stuff, it's hard to see sometimes. Oh, 14 on the font. Cutter diameter. Alright. Down here we'll go number of teeth. So you need to know the number of teeth on your tool. If it's an end mill, 2 flute, 4 flute, that's your teeth. This will be your feed per tooth. Alright. So down here we'll go 8,000 RPM if you have an 8,000 RPM spindle. Then 10,000 RPM if you have a 10,000 RPM spindle. 12,000, 15,000, 18,000, and it can go on and on. All the way up to, I guess they have adapters that'll go to like 60,000 now. Go make that 14 bold. Let's center all that stuff so it looks pretty. So centered. Actually, yeah, that'll work. So these boxes will be where the user input is. So come down here wherever properties is. Format cells, there we go. Go over to protection. You don't want these locked. So, not locked. These two, highlight, right click, format cells, not locked. Okay. Over here, pick you a square, it doesn't really matter. So that's your RPM. 14, what? 14. I'm going to do that, make it simple for me. So you need to know your RPM and your feed per minute. Alright, spread that out. Over here is where it's going to spit out your RPM and your inches a minute. Then we'll go make us a little cheat sheet table over here. So let's put SS for stainless. Just highlight it all, make it 14. So stainless steel. Then you got your mild steel. Then you got your aluminum. I don't want it to be ALU. Alright. Now, there'll be different tools you're using with that. So we'll start with the inserted drill. Inserted drill. And stainless, 300 surface foot a minute. Mild steel, say 600. Aluminum, 1200. So these numbers, I've used them before, and they're a pretty good starting point. Depending on your grade of stainless, or mild steel, or aluminum, you're going to have to tailor these numbers. So these are good for your stainless. It's your 303, 304. These stainless numbers will work. Mild steel, 1018, something like that will work. These numbers will all be good for your aluminum, 6061, 6063. These are a good starting point for your numbers. If you're unsure, you can look at this and say, okay, well, you know, I know these numbers are going to work. And if you have certain inserts you use, like in stainless, they've got some inserts that they recommend to run at 500 surface foot. To get better numbers, if you run the same inserts, talk to your tool vendor and get them to get a rep out. If it's ISCAR, get a ISCAR rep out, and he can go through and tell you really good numbers that are going to get you the most efficiency. So that's how you would do that. Just for quick numbers, you can look on the back of the box of inserts, and it'll have a VZ or velocity, and it'll tell you what surface foot you can be in for what material. That's another way to get those numbers to run the most efficient and get the most money out of your inserts. So we're going to keep typing though. Drill, high-speed steel. Drill, carbide, and that's for solid carbide. So let's go end mills. End mill high-speed steel. End mill carbide. And then we'll do tapping. So drill high-speed steel, 75 surface foot. Mild steel, 125. Aluminum, 350. Drill carbide, 350. Mild steel for a carbide drill, 500. Trump don't jive with those numbers. Aluminum, 1200. I think that's probably wrong. And that one's wrong. Those are probably better numbers to make it safe for people who aren't familiar with machining and drilling with carbide and stainless and all the different stuff. These are good numbers that'll get you a good starting point. So end mill high-speed steel, 55. Mild steel, high-speed steel end mill, 125. Then end mill high-speed steel and aluminum, 500. Let's look at the carbide. So stainless, 300 surface foot. 500 surface foot. 1,000 surface foot carbide. You can go faster than that. These started out, they came from the machinery handbook, is where I started getting these numbers from originally. And then I've been slowly adjusting them. So tapping, stainless steel, you probably want to start around 15, depending on what kind of tap. Manufacturer's recommendations are always best though. So mild steel, nah, we're gonna go 50. Then aluminum, go 150. Let's call it 100. 125 just to be safe. Alright. So, let's go put some color in this. Highlight that, and we'll go make it green. You can make these any colors you want. I don't really care what color it is. Let's make that one yellow. Make that one yellow. These, if you hold control, you can select multiple cells. Make those orange. Alright, so this stainless, we'll make it pink. Oh. Control Z, I don't like it changing my colors. So let's go up here. Make this orange. Highlight those cells. Come up here to this color palette. Make it that color green. What do we want to make this one? Blue? Blue works. Yep, I like that. Okay, so for these formulas, what we're going to do is, this formula is going to be, go up here, click in this formula bar, tell it you got to highlight your cell first. Nope, hit escape. Highlight this RPM cell, tell it equals. So that cell equals 3.82 times B3. So B3, your surface foot, times B3, or your cutter diameter, I'm sorry, and then divided by surface foot. So that's our B3, or B, what? I'm losing my mind, divided by B4. No. 3.82 times surface foot divided by diameter is the formula. So 3.82 times B2 divided by B3. That'll give you your formula. So then your feed per minute is going to be equal to your feed per tooth times number of teeth times RPM. So that equals, let's see, that equals feed per tooth times number of teeth times, oh no, times your RPM. And you can click these cells to select on, so hit enter. Now let's go here and see if those work. Surface foot, 100 surface foot a minute. Cutter diameter, 0.5. So it gave us our RPM. See if it gives us the feed per minute, or inches per minute. Let's say it has one tooth, and it's 3 thousandths per tooth. So the feed would be 2.29 inches a minute. We'll change this to inch a minute. So there you go with that. Now for our 8,000 and 10,000 and all those, to do that, we're going to use our number of teeth and feed per tooth and just multiply it times the spindle diameter. So this will equal this times this times 8,000. So it'd be 2.4 inches a minute at 8,000 RPM. That ain't right. That can't be right. Let me go over here and look at something. Yeah, that's crazy. Oh, yeah, I missed a 0. There we go. Now that looks better. So, this equals that times 10,000 RPM. 10,000 looks close. That's about right. That equals this times number of teeth times, nope, times 12,000. $15,000 spindle equals feed per tooth times number of teeth times 15,000 RPM. 18,000 RPM spindle, I'm sure y'all got this by now, equals number of teeth times feed per tooth times 18,000 RPM. So now we've got all these numbers filled out. Let's go and make that bigger. These two. 14. Alright, so we got all that stuff filled out. Let's just go do a save real quick. Because we know it works, so we're going to save it. Now we're going to go up here to, where is it? Protect sheet. We want to protect it. We want people to select unlocked cells. That way you can just hit tab. Put your password in there so you don't go messing stuff up. CNC. And we've been typing in caps, so it'd be capital. Type it again. CNC. Enter. Let's see here. I'm hitting tab. It only goes to those, so you can't go jacking with stuff. Let's unprotect it real quick. Type in our password. Let's put a password equals CNC in caps. Because once you get more familiar with machining and what surface feet you can use, you're going to start changing these numbers. I mean, that's a given. Because they're just a starting point. So, now let's go protect the sheet. Again. You know your password's down here, so when you get ready to start making changes and feel more comfortable with what speeds and feeds you've found out works great for the tooling you have, start editing this. Make it your own. Let's go save it. File, save. Now it's saved. So whenever you start programming, when you open up your CAM system, open up this calculator so it'll be there. You can just swap over here. Okay, I know I'm running me inserted drill in 300 series stainless in 303, 304, 300 RPM. That's a 2-inch inserted drill. You say it has one tooth and you go 3/1000ths per tooth. Well, there's your RPM, 573. And there's your feed, 1.7 inches a minute. Alright, that's about it for this. And we'll see y'all later.